Simplify each expression. Here we have three exponential expressions where we have a fraction in parentheses raised to a power, and there's a rule that applies in these sorts of situations. If we have a fraction, like x over y, raised to a power, such as n, what we can do here to get rid of the parentheses is distribute that exponent to both the numerator and the denominator, giving us x to the n over y to the n. We can use this in all three of these problems to get rid of the parentheses and create a simpler expression. Let's start with the first one, 2x over 3 all to the third power. Here we can distribute that exponent to the numerator and the denominator. That gives us 2x cubed all over 3 cubed. And in the numerator, we actually use a rule that says if we have a product raised to a power, that power can be distributed to each of the factors. So we're going to have 2 cubed times x cubed all over 3 cubed. And then we can go and cube each of those things on their own. 2 cubed is 8, x cubed is x cubed, and 3 cubed is 27. So we end up with 8x cubed all over 27. We can actually get the same answer a little bit more quickly by taking this exponent of 3 and distributing it to each of the factors in the numerator and denominator all at once. If we took 2 and cubed it, that gives us the 8 that we have here. If we cube x, that gives us the x cubed. And if we cube the 3 in the denominator, that gives us the 27. So let's try the next one, but doing it a little bit more efficiently. Here we have 3y squared over 4 all squared. Now we know that that exponent of 2 will get distributed to everything in the numerator as well as the denominator. So let's take all of those factors and square them right away. 3 squared is 9. Y squared squared is y to the 4th. And 4 squared is 16, giving us the answer much more quickly, 9y to the 4th all over 16. Let's look at the last one. The last one, we've got 4x to the 5th over 6x squared, all cubed. Now here there's two ways to do it. We're going to do it kind of the by the book way first, based on the rule that we've learned, and then we're going to see that there's a shorter way to do it. Now here we have an exponent 3 on a fraction, so we can distribute that exponent to all of the factors in the numerator and the denominator. So here in the numerator, we've got 4 cubed. 4 times 4 times 4 is 64. And then x to the 5th cubed is x to the 15th. We multiply those exponents. In the denominator, 6 cubed is 216. And then when we take x squared and cubed it, we get x to the 6th. And then we've got a bit of reducing to do. Now, let's see. If we look at the coefficients, 64 and 216, I think those are both divisible by 8. But I'm not sure. They're definitely divisible by 4. Let's reduce by 4. If we do that on the top, 64 divided by 4 is 16. 216 divided by 4 is 54. And then if we look at those x's, x to the 15th over x to the 6th, we know that we subtract those exponents, and that gives us out front x to the 9th. 15 minus 6 is 9. But we can still reduce the coefficient, the 16 over 54. Those are both divisible by 2. So if we take the 16 and divide it by 2, that gives us 8. And 54 divided by 2 is 27. So we end up with 8 27ths x to the 9th. Or if you wanted to keep that x in the numerator, we've got 8x to the 9th over 27. Both of these are perfectly acceptable. But those coefficients were huge, 64 and 216. There is an easier way to do this. And it's to recognize that in our original problem, 4x to the fifth over 6x squared, all raised to the third, we have a fraction on the inside that we can simplify. All right? Even though the rule says that we're supposed to distribute that exponent to the numerator and denominator, which is true, we have a fraction on the inside, and whenever we have a fraction that can be simplified, usually it's helpful to simplify it. So let's start by simplifying the inside. If you look at that 4/6, we know that that can be reduced to 2/3. And if you look at the x's, x to the fifth divided by x cubed, we subtract the exponents, and that gives us x cubed. And now that we've done this, we can distribute that exponent to everything on the inside, and the things on the inside are a lot smaller. If you take that 2 and cubed it, you get 8. 3 cubed is 27. And then on the side, x cubed cubed is x to the 9th. And we get the same answer that we had before, but with a lot less work. So my suggestion to you is whenever you see something that can be simplified, and you know that it can be simplified, you should start there because it's going to make the rest of the calculations much easier.